So let us start our class. Okay. So thermodynamics, most of the topics we have covered. The only last topic that was left was our pure substance. Okay. So we will complete pure substance today. Okay. So after completing pure substance today, I'll just prepare a assignment. Okay. So maybe tomorrow we have that we have some one question session of our thermodynamics, and we will discuss some questions. Okay, because the questions is required for your this thing thermodynamics actually, because other subjects the questions are like very easy, and also we have solved some questions, so you can connect your concept and your formula with your question. But thermodynamics we haven't solved such any such question. We have only dealt with the theory part, so having a question session is important. So probably tomorrow. Today our thermodynamics syllabus will be entirely over, and I think thermodynamics also we did in too much detail. Okay, so we'll have a question session tomorrow. Okay, and then I told you Sunday we will be having a session for your aptitude. Okay, then we can start our that thing what is said, mm, fluid mechanics. Okay, yeah, fluid mechanics we can start from Monday. Okay, so most of your subjects are over. Okay, what we have dealt is your MT we have covered, CRE we have covered. Okay, IPC, whatever doubts you were having we have discussed. Heat transfer also important concepts and doubts that you were having we have discussed it. Okay, whatever like demand you did that. Okay, heat transfer this many topics are required that we did. You said that thermodynamics it is left, we need it in detailed format, so we provided thermodynamics. Okay, the next possible subject will be our FM, and also too much inform like too much request for aptitude is coming, so aptitude also we will be doing it. Okay, so aptitude we will be doing on Sunday, so be prepared for that. Okay, once you attend that session, so aptitude your aptitude will be over. Okay, after that we can only our FM will be left. Sir, in heat transfer could you please take boiling and condensation? Okay, chalo, one more request has come, that is our boiling and condensation. बॉइलिंग एंड कंडेंसेशन, ठीक है, इसको भी हम लोग डिस्कस कर लेंगे. ठीक है, ये हो गया, 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 ये भी हो जाएगा. चलो, तो बॉइलिंग एंड कंडेंसेशन हम लोग डिस्कस कर लेंगे, कोई दिक्कत नहीं है. फिर हम लोग अपना आराम से वी विल स्टार्ट अवर एफएम. ओके okay, let us understand pure substance. So for coming pure substance, let us understand what this pure substance actually means. Okay, so pure substance means any substance any substance that is having two things. What are these two things? It is chemical composition and chemical aggregation. Okay, chemical composition means simply means chemical formula. That means what? That means what? That in any of the phases, like in liquid phase, in solid phase, in gaseous phase, in any of the phases, in any of the phases, that particular substance is having the same chemical representation. For example, H2O, that is water. If water is present in liquid phase, then also you will mark it by H2O. If it is present as water vapor, then also you mark it as H2O. If it is present as ice, then also you mark it as H2O. So that is your example of your water is known as your pure substance. Not all substances are pure substance. Please understand. Okay. So water is your pure substance. And the second thing is chemical aggregation. Chemical aggregation simply means that many things, if you mix it together, but it will be considered as one. Okay. It is just several things mixed together, but considered as one. Okay, considered as one means, for example, I just tell you, for examples, suppose water vapor and water, you form a mixture, but it will be considered as H2O only, no? Suppose you are having a mixture of ice and water. Suppose in a glass, what you do, suppose you take a glass, in that glass you take liquid water and you put 2 cubes of ice in that, but still the entire formula will be only H2O, no? So this is your chemical aggregation. So if any substance is satisfying these two conditions, that is chemical composition and chemical aggregation, then that particular substance is known as your pure substance, and your water is an example of your pure substance. This thing is clear? This thing is clear? Okay. If this thing is clear, then we will just move forward. Let us understand few things. Okay. Let us understand how phase change and all these things actually happens. Okay. Please understand. Suppose you are having minus 20 degrees centigrade ice that is present at minus 20 degrees centigrade, or let it be at minus 10 degrees centigrade. Okay. From here you are going to 150 degrees centigrade vapor. From here you are going to 160 degrees centigrade vapor. Okay. So that means actually you are going from solid phase to superheated vapor phase. Superheated vapor means the vapor that is above its boiling point. Clear? What I'm trying to say is that suppose you are having water. So what is the boiling point of water? At normal room at normal room pressure, like normal atmospheric pressure, the boiling point of water is 100 degrees centigrade. So if you provide this 100 degrees centigrade to your liquid water, it will convert into water that is vapor phase, that is in vapor phase, and you will call it as water vapor. Okay. Now this water vapor, this vapor phase is present at 100 degrees centigrade. Suppose you put more amount of heat to it, so then it will go to superheated vapor phase. Superheated vapor phase. Okay, that is suppose 110 degree, 120 degree, something like this. It will go on increasing the temperature. Okay, so this vapor now, this water vapor that is now present with you, that is above its boiling point, this will be called as superheated vapor. This thing is clear? So now understand. So what are the phase changes that will actually take place? Please understand. So from minus 10 degree centigrade ice that is in solid phase, it will go to 0 degree centigrade ice that is still in solid phase. From this 0 degree centigrade ice, it will go to 0 degree centigrade water that is your liquid phase. From this 0 degree centigrade water, it will go to 100 degree centigrade water that is still in liquid phase. From this 100 degree centigrade water, it will go to 100 degree centigrade vapor that is your gas phase. From this 100 degree centigrade vapor, it will go to 150 degree centigrade vapor that is also in gas phase. So these entire changes are going to happen. Okay. In these entire changes, what are the heats that are involved? Let us understand. So from minus 10 degrees centigrade ice that is in solid phase to 0 degree centigrade ice, what will be involved? Your MC delta T will be involved. That is your sensible heat. This is your sensible heat. From 0 degree centigrade ice, it will get converted into 0 degree centigrade water. This will be your latent heat. That is M lambda. This is your latent heat. From 0 degree centigrade water, it will go to 100 degree centigrade water. Again, MC delta T. This will be your sensible heat. Then from 100 degree centigrade water to 100 degree centigrade vapor. So again, M lambda. This is your latent heat. Then again 100 degree centigrade vapor to 100 degree centigrade, so 150 degree centigrade vapor. Again MCP delta T. That is your sensible heat. Now please understand, as water is a pure substance, so its specific heat, that is C, is generally constant. Okay, so this sensible heat, this sensible heat, this sensible heat, this M and C will be constant. However, the delta T will change. Here the delta T was 0 minus of minus 10. Here the delta C will, here there will be no delta C. You know that phase change occurs at constant pressure. Sorry, phase change occurs at constant temperature. So see, here only latent heat is involved, no sensible heat is involved. Again here sensible heat is involved, whether 100 minus 0. Here again phase change is occurring, so no temperature change, constant temperature. Here again phase change is occurring, so delta T will be 150 minus 100. This thing is clear? This thing is clear? यहाँ तक clear है? Okay. If this thing is clear, let us understand few more things. What are those few more things? That is, once you are having liquid phase that is below its boiling point, that phase is actually known as your subcooled region, subcooled region. Okay, or this is also known as your compressed fluid region. That means simply what? It is liquid below boiling point. Okay. Once this liquid reaches its boiling point, that means this region is known as your, this region is known as your saturated region. Saturated region means both vapor and liquid mixture will be present. What I'm trying to say here, please understand what I'm trying to say here is both vapor and liquid mixture will be present means what I'm trying to say is that suppose you are having 100 degree centigrade water. So at one instant that entire water will not get converted into vapor. No, it is a constant process. It is a time taking process. Along with time, slowly, the water will get converted into vapor. So at this in this saturated region, what you are going to get is in this saturated region water you will get a mixture of your vapor and liquid. You will get a mixture of your vapor and liquid. Vapor plus liquid mixture. This exists exists this exists this exists at your saturated region. Okay. Now you come to your superheated region. This region is known as your superheated region. In the superheated region, what is going to be present is that vapor above boiling point. This entire thing is clear or not? This entire diagram is clear or not? This is very important to be understanding. This is very important. This entire thing is clear or not? This entire thing is clear? Okay. Now come. Now see. Now see. Now see. Now suppose you want to draw. Now suppose you want to draw a TV diagram, a temperature versus volume diagram. So actually a temperature versus volume diagram is going to look like this. It is going to be a bell-shaped curve like this. Okay. In this bell-shaped curve, what is going to happen is that you're going to line like this and line like this. Please remember, in that case, your pressure is going to be constant. Okay. Now what is going to happen is that this region is your L, this region is your V, and this region is your L plus V. That means this L region is your subcooled region. This L plus V region is your saturated region. That means both vapor and liquid mixture will be present. And this V region is your superheated region. That is only your vapor will be present. This thing is clear. And this point is known as your critical point. Okay. This curve is known as your saturated liquid curve. And this curve is known as your saturated vapor curve. Saturated vapor curve means vapor at boiling point. Saturated liquid curve means liquid at boiling point. ये चीज क्लियर हुआ? Okay. Suppose you have drawn this curve at some pressure, at you're keeping constant pressure. That is okay. Very good. You are keeping constant pressure. Very good. No problem in that. Okay. No problem in that. You have kept constant pressure. Okay. No problem in that. Okay. But what I'm trying to say is that suppose at this pressure is your P1. Okay. Suppose you increase your pressure. So if you increase your pressure, your boiling point will also increase. So this curve will shift like this. It will have the same nature, but it will be shifted like this. Okay. Suppose you increase your pressure more. So this curve will shift like this. You will get a curve like this. Suppose this is your P1, this is your P2, this is your P3. Where your P1 you have kept constant, P2 also constant, P3 also constant. But however, your P1, P2, P3 having a relation like this. P3 is the highest, P2 is the lowest. P2 is lower than your P3 and P1 is the lowest. This thing is clear. This is known as your temperature volume diagram for your uh, what to say, pure substance. Now let us come forward. Now let us come forward to an extension of TV diagram. Because extension of TV diagram, why we want to see is that we have understood the relation between your liquid and volume. Okay, very good. But how solid is also there, no? So from solid to liquid, see here. Actually, here what happened? From solid it went to liquid, then from liquid it went to gas. So two phase changes are occurring, but here only was one phase change is there. So let us understand the extension also. So actually your curve, this entire TV curve, it looks like this. Okay, see, this is your solid region, this is your solid plus liquid region, this is only your liquid region, this is your liquid plus vapor region, this is your vapor region. This thing is clear? Very important. This curve is your saturated solid curve, this curve is your, and this curve is your saturated liquid curve at different temperatures. You are getting it, no? This curve will be at 0 degree centigrade, this curve will be at 100 degree centigrade. This is your saturated vapor curve. Okay, यहाँ तक clear है? So before this curve, that means this region only solid will be present. This region solid and liquid both will be present. This region only liquid will be present. This region solid, liquid and vapor will be present, and this region vapor will be present. यहाँ तक clear है? So in this TV diagram, we have only represented till here. Clear? In this TV diagram, we have only represented here. But if you want to extend this TV diagram, it will look something like this. यहाँ तक clear है? This thing is clear? And of course, when you draw your TV diagram, your pressure is equals to constant. That means some pressure you have taken and you have kept that pressure constant, and you are seeing that how the phase is changing as you are going on increasing the temperature. यहाँ तक clear है भाई? बताओ, जल्दी बताओ यार. ये चीज clear हुआ? Okay. Okay. If it is clear, now let us come to our PV diagram. Now let us come to our PV diagram. TV diagram we have seen. We have seen that how your temperature and volume is varying and how the curve looks when you have kept your pressure constant. Okay. Let us understand that if you keep your temperature constant, how your pressure and volume curve is going to look like. So, like this. Again like this. So your curve will look something like this. Okay. This is your L plus V. This is your L, and this is only your V. Okay. And this is nothing but your critical point. Okay, here only liquid is present, this is subcooled region. Here only vapor is present, this is superheated region. This is subcooled region, and this is your saturated region where your liquid and vapor both will be present. This is subcooled region. This thing is clear? This thing is clear? If you want to see the extension of this PV diagram, so how does this extension of this PV diagram looks? A little different, something like this. Okay, something like this it looks like. Okay, this is your vapor, this is your L plus V, this is only your L, this is your S plus L, and this is only your S. This is extension of PV diagram. Okay, why this change has happened here? In this curve it is going from top to bottom, in this curve it is coming from bottom to down. Why it is coming? If you know it very clearly that as you go on decreasing the pressure, as you go on decreasing the pressure, if you decrease your pressure, so your volume will go on increasing, because your pressure is inversely proportional to volume. Clear? That means what? That your liquid is getting converted into your vapor. Okay, if you go on decreasing the pressure, so your boiling point is also going on decreasing. No, you're getting it. No, what I'm trying to say. Suppose you are keeping your temperature equals to constant. In this PV diagram, your temperature equals to constant. So as you go on decreasing this diagram, decreasing this pressure, your boiling point will also go on decreasing. No, so boiling point is decreased. That means what? That you go on decreasing the pressure. Okay, suppose you are having liquid. Understand this thing. Suppose you are having liquid at 1 atm pressure, 1 atmospheric pressure. Okay, now you have decreased to 0.9 atm. So at this 1 atm, the boiling point was 100 degrees centigrade. Suppose at 0.9 atm, the boiling point is suppose something like 80 degrees centigrade. Okay, you have decreased it further to 0.8 atm. Suppose the boiling point now is 60 degrees centigrade. Suppose you have decreased it further to 0.7 atm. The boiling point now is 50 degrees centigrade. Suppose you decrease it further to 0.5 atm. The moment you decrease it to 0.5 atm, suppose the boiling point is 25 degrees centigrade. That is your room temperature. Suppose you were performing this equation at room temperature, where your temperature was equals to constant equals to 25 degrees centigrade. So the moment that the pressure you decrease it to 0.5 atm, your liquid will start converting into your vapor. Clear? At 25 degrees centigrade itself. At 25 degrees centigrade itself. This is your applied pressure. This thing I think in one of the lectures, I think this thing I've already discussed, that your the applied pressure, once it falls below its vapor pressure, your liquid starts vaporizing. This thing I have discussed, no? Where I have discussed this thing? In one of the lectures I have discussed this thing. In mass transfer, I think. Yeah, mass transfer, I think. Yeah. Yeah, distillation starting I've discussed. So this is a very important concept. That's why I taught you this at that time. Okay, because this is a very important concept, that your liquid will continue to be in liquid till the applied pressure is higher than its vapor pressure. The moment the applied pressure on the liquid falls below its vapor pressure, it will convert into vapor. Why it will convert into vapor? Because this vapor pressure is actually related to its boiling point. You are getting it, no? This vapor pressure is actually related to its boiling point. Okay, so if you go on decreasing the applied pressure on it, so suppose in the vapor pressure, what is going to happen? It is going to be related at its boiling point. Okay, so suppose at 25 degrees centigrade, the boiling point, like at 25 degrees centigrade, suppose the vapor pressure of water is suppose like 0.6. Okay, 0.6 atm. Suppose this is the vapor pressure of water, P vaporization. Okay, so if you go on decreasing the pressure, applied pressure, you are decreasing to up till 0.7, it was continuing to be in liquid phase. Okay, the moment you make it 0.5 atm, now this 0.5 atm is lesser than its vapor pressure, that is 0.6 atm. This vapor pressure is related to your 25 degrees centigrade. Okay, you have understood this equation also. I have taught you, no? Antony equation, PSAT is equals to A minus B by T plus C. This equation, Antony equation. This Antony equation gives the relation between your vapor pressure and your temperature. That a particular temperature, what will be the vapor pressure of a particular component? Okay. So your temperature is directly related to its vapor pressure. So suppose at 25 degrees centigrade, the vapor pressure of water is 0.6 atm. So you decrease the applied pressure, you decrease the applied pressure. The moment it falls below 0.6 atm, the liquid will start vaporizing. Vapor. This concept is clear. So that's why we get a diagram like this. Okay, here the applied pressure was high, so your liquid was continuing to be in liquid. Okay, you are going on decreasing the pressure, decreasing the pressure, decreasing the pressure, decreasing the pressure. This is the point when you get to your 0.6 atm. Okay, that is the vapor pressure. The moment you fall below the 0.6 atm line, your liquid will get converted at 0.6 atm only. Like when your applied pressure and your vapor pressure both are equal, so the liquid will start vaporizing, but not entirely it will vaporize. It will form a liquid and vapor mixture. Okay, the phase change will take place. These things will happen, and when you decrease it further, so it will get converted into vapor completely. So you will get a superheated region. यहाँ तक clear है? यहाँ तक clear है? This thing is clear? Okay. So this was the main concept of your this was actually the main concept of your what to say. Hmm, क्या बोलते हैं इसको, प्योर सब्सटेंस. Okay. This is the main concept of your pure substance. Okay. So this is the thing. ठीक है, थोड़ा सा और आगे बढ़ते हैं. If till here it is clear, then we can move forward. Okay. Let us understand what is phase change. Some concepts of phase change. Let us understand. Okay. So phase change, what can happen? Solid to liquid, liquid to solid. Okay. Liquid to vapor, vapor to liquid, and solid to vapor, and vapor to solid. If some component is going from solid to liquid, we say that it is melting, or this melting is also called as, अबे क्या हो रहा है भाई? Melting is also called as, melting को also क्या कहते हैं? What is melting also called as? Melting is also called as fusion. Okay. From liquid to solid, it is simply known as freezing. From liquid to vapor, it is known as vaporization. From vapor to liquid, it is known as condensation. From solid to vapor, it is known as sublimation. And from vapor to solid, it is known as ablimation. Ablimation. Okay. These things are happening. Okay. Now, one more concept is there. One more concept is there. That is, for any substance, for any general substance, what actually happens is that if you go from solid to liquid, then your volume expands. And if you go from liquid to solid, then your volume contracts. For anything you can see, you can just take example for your wooden door. Your wooden door, what happens when your summer vacation, when your like summer season comes, then sometimes it happens, no, that the wooden door, the wood has expanded, or some you are having some metal door, so the metal has expanded, so now the door doesn't close properly. Okay. However, in the winter season, that problem doesn't arise. Okay. For any general substance, this thing happens. However, water shows a very strange phenomena. Water shows a very strange phenomena. Okay, please understand what happens. Water shows a very strange phenomena, and this phenomena, like, तुम लोगों को पता नहीं होगा. When I'll explain, actually, I want to explain the concept behind this also. Okay, this is like specifically derived by nature. This concept is actually specifically like it is like, you can tell that it is designed by God itself. Okay, why? I will just explain it to you. Please understand. Water shows a very specific phenomena, very strange phenomena, that when it goes from solid to liquid, actually it contracts, and when it goes from liquid to solid, actually it expands. Actually it expands. Okay. How this is happening? That means what is going to happen is that when you turn liquid water to your ice, its volume increases. And when you turn from ice to liquid water, its volume decreases. Okay. This thing is clear? This thing is clear? Okay. Do you want to understand why this thing happens? Like how it is designed by God? Okay, now understand. Many times you have heard, no, that suppose in childhood, what we used to do, we used to take a bottle, we used to fill it up with water, and then we used to put it in the freezer. Okay. And our parents used to say that don't put it in the freezer because the bottle may explode. This thing has happened, no, with everyone. This thing has happened. Okay. Why they were saying this thing? Because when this water converts into your ice, if you are filling this bottle, if you are filling this bottle till the brim, and you are freezing, you are filling it and you are putting it in the freezer to freeze it. So now this entire water, when it gets converted into vapor, sorry, when it gets converted into ice, its volume is going to expand. But the bottle is fixed, no, the bottle volume is fixed, so the bottle has no space for expansion. So in that case, what is happening? Your bottle will burst open. Okay. But actually, actually all of our bottles was made of plastic. So plastic is having some elasticity. So actually that the bottle used to bulge up, and it used to look like something like this. हाँ, ऐसा होता था ना. बॉटल फूल के पूरा वो जो आइस है उसको अंदर कैप्चर कर लेता था, क्योंकि प्लास्टिक है, तो प्लास्टिक इज हैविंग सम इलास्टिक प्रॉपर्टीज. दिस थिंग इज हैपन, नो. Also, what happens is that suppose you take a glass of water. Okay, in that glass of water, what you do is that you fill it to the brim with your liquid water. Okay, and then you put six ice cubes in that. You six ice cubes in that. Six ice cubes you put it, and you fill this water to the brim. Okay, so now what is happening is that this entirely water is filled up to the brim, and also six ice cubes are there. Okay, or four ice cubes are there. So what is the obvious thing? That when these ice cubes will melt and they will convert into liquid, so the amount of liquid in the in the glass is more, so the water will spill. This is the obvious phenomena. But actually what happens, the ice cubes melt also. If all the six ice cubes melt also, not even a single drop of liquid is going to spill. Not even a single drop of liquid is going to spill. This thing is all this thing has also happened with you, no? This thing also you have seen, no? जल्दी बताओ, ये चीज भी तो देखे हुए होगे. Now see why this phenomena is designed by God for water. Now see, now see. So suppose you are having lakes, ponds. Everywhere you are having water bodies, no? All the water bodies in the winter region. Winter region. That means suppose in Siberia, okay, or suppose in Antarctica, or suppose anywhere, okay. So fish, there are fish in these lakes, or water organisms are there. Fish है, shark है, blue whale है, कुछ भी है. They are living, okay. Crocodiles also. They are living in these lakes. They are living in this pond. Now, if water would behave as a general substance, and in winter, when this top surface of this lake freezes and its volume decreases, the mass is same. Please understand. Here, what is going to happen? Volume increase and volume decrease. That means volume is increasing, volume is decreasing, but the mass is constant. So your m is equals to Vd. Clear? So that means volume increases means what? Your density must decrease. And here volume increases means what? Sorry, volume decreases means what? Your density is increasing. So that means your ice density, your density of your ice is actually less than your density of your water. For water, this special phenomena happens. Till this thing you are agreeing, no? That if volume is increasing and the mass is constant, then the density is decreasing. That means for when you are going from liquid water to ice, the density is decreasing. That means the density of ice is less than the density of water. That is the reason when the top surface of this lake freezes, this like suppose this entire circular disk of ice, it floats on the surface of the lake, and the entire region below the lake stays as liquid only, because now it doesn't come in contact with the cold environment, and it does not convert into ice, and all the living organisms, they can live peacefully inside the lake below the top surface of the ice. Had it not happened, please understand what would happen. The moment the top surface of the water gets freezed by the cold environment, so density of ice would have been greater than your density of water. So this top surface would become heavier than the bottom water, and this will sink down like this. Then the next surface, it will again sink down as a circular disk. Then the next, then the next, and like this continuously. This there will be circular disks, or any shape of the lake, depending upon the shape of the lake. Ice will go on sinking down, sinking down, sinking down, and a time will come when this entire lake freezes, and all the water living organisms, or the water organisms that are living in the lakes and the ponds, they will all die. Clear? But this thing cannot be allowed, no? Or else in winter season, every water organism will die. In winter season, when the top surface of the lake freezes in the cold regions, so all the water animals will die, no? So that's why God said that no, this thing cannot happen. For all other substance, this thing is true. But for water, we cannot let this thing happen. And what we can do is that our raw ice will be less than our raw water, so that once the top surface freezes, it will stay at the top, its density decreases, so it will float on the water surface, and it will keep the rest of the water warm. It will not allow it to freeze, so that the water organisms can live. and they don't die. This concept is clear or not? This concept is clear or not? अबे एगो लड़का लिख रहा है ग्रेट सर। अबे ये चीज पता है, मतलब प्योर सब्सटेंस तो ऐसे तुम लोग पढ़ लोगे, स्पेशल केस बाय गॉड, या गॉड डिजाइन दिस थिंग। Okay, now let us not waste time, let us come to our syllabus. Okay, so triple point, what is triple point? That all your liquid, your vapor, and your solid state all will occur at the same temperature. Okay, so this is your P, this is your T, so this is your triple curve, this thing. Okay, this is your triple point. At this triple point temperature, what is going to happen is that this is your solid region, this is your liquid, this is your vapor region. Okay, so all the curves are going to serve like all the curves. This curve is known as your fusion curve. Fusion means melting. So fusion curve. This curve will be known as your uh, vaporization curve, and this curve is known as your sublimation curve. Because very easy, from solid to liquid, that means melting is happening, so fusion. From liquid to vapor, this is vapor region, no, here. So from liquid to vapor, vaporization is happening, so vaporization curve. And from solid to vapor, directly sublimation is happening, so sublimation curve. And this curve is drawn between pressure and temperature. And this particular point that you get here, where all the curves, they converge together and they form a single point, this point is known as your triple point, where liquid, vapor, and solid, they exist at the same point, at the same temperature, simultaneously. Clear? This thing is clear? यहाँ तक clear है? Okay. चलो. This many concepts were there. Now let us come to a little bit about our that thing. What to say? Let us come a little bit to our numerical part. Okay. So let us understand some numerical concepts also. So suppose this is your typical TV diagram. Okay, this is your typical TV diagram. This is liquid plus vapor. This is your vapor. Okay, so this temperature, okay, this, let it be T actual. This temperature, this is your T saturation, that is your saturation temperature. This temperature, this is also at T saturation, because your phase change from liquid to vapor is going to have at a constant temperature. And this temperature, this is T actual. T actual means, what I'm trying to say is that this T actual is that the temperature at which the superheated vapor will be present. Okay, T actual is the temperature at which superheated vapor will be present. This T actual is the temperature at which your liquid water will be present. Okay, like from, if you go from, suppose you want to go from 10 degrees centigrade liquid water to, suppose first you have to go to 100 degrees centigrade. इसको थोड़ा लंबा बना दिया भाई. Suppose you want to go to 100 degrees centigrade liquid water, then you want to go to 100 degrees centigrade vapor, and then you want to go to, suppose, 110 degrees centigrade superheated vapor. Okay, so all these things are going to happen. Let us, superheated vapor means completely vapor only, so vapor phase. Okay, so this region will be known as your subcooled region. In this case, this is your T actual. These two temperatures are your T saturation. And when you will come to your superheated phase, this will actually become your T actual. Okay, and this is nothing but your saturation region. This is not actually your saturation region. Okay, so what is going to happen in subcooled region? Can we say that our T actual is less than T saturation? And also for your PV diagram, your P actual is greater than your P saturation. And from here you can get your degree of subcooling. This is known as degree of subcooling. That is simply equals to T saturation minus T actual. That is, for this example, it will be simply 100 degrees centigrade minus 10 degrees centigrade. For your saturated region, for your TV diagram, your T actual will be equals to your T saturation. And for your PV diagram, your P actual will be equals to your P saturation. That means what is going to happen is that T actual in your saturated region will be some temperature here, some temperature here, some temperature here, and all these temperatures will be constant only, no? Because phase change is occurring at constant temperature. So all these temperatures will be same only. So in your saturated region, your T actual is equals to your T saturation. In your superheated region, what is going to happen is that in your TV diagram, your T actual is going to be greater than your T saturation, and your PV diagram, your P actual will be less than your T saturation, and here you get a degree of superheat that is equals to your T actual minus T sat. For this example, it is just 110 degree minus 100 degree. That is again equals to 10 degree. Clear? So for PV diagram also you have seen, no? PV diagram you have seen it here. See here, the P actual in the subcooled region, it is greater than the P saturation. In the same, like in the saturated region, all the pressures are going to be same. So in this case, your P actual will be equals to your P saturation. Okay. And in the superheated region, your P actual is less than your P saturation. This is your P sat. Clear? This concept is clear. Okay. Now come to the next concept. Now we have a concept that is known as dryness fraction. This gives quality of mixture. What this dryness fraction actually tells is that, okay, this is designed for your saturated region. Okay, this also please remember, this is for your saturated region. As because in saturated region, what is going to happen is that your vapor plus liquid both will be present, no? So you will get some mass of vapor, you will get some mass of liquid. This thing is clear, no? You will get some amount of vapor will be there, some amount of liquid will be there. So you will get a particular mass of vapor, you will get a particular mass of liquid. So you say that, okay, let dryness fraction be equals to x, and that is equals to your mv by mv plus ml, and that will give us the quality of the mixture, or it will just give us the fraction of vapor present. The fraction of vapor present in vapor plus liquid mixture at saturated region. This thing is clear. This thing is clear. And if this x, it is giving the fraction of vapor present, it is giving us the dryness fraction. Dryness fraction means simply the fraction of the vapor that is present in the vapor liquid mixture. Then let us define x dash also. That will be ml by mv plus ml, and that will simply be equals to 1 minus x, and this x dash we will call it a wetness fraction. This we will call it as wetness fraction, and this will simply represent the fraction of liquid present in vapor plus liquid mixture. The fraction of liquid present in vapor plus liquid mixture. This thing is clear. And also from this thing can we tell that your dryness fraction, also from this thing can we tell that your dryness fraction at this point is x equals to 0. Your dryness fraction at this point is x equals to 1 and your dryness fraction in this region will be greater than 0 and less than 1. Can we tell this thing also? जल्दी बताओ, जल्दी बताओ भाई. Okay, because this region is entirely liquid region. This region, so no vapor will be present, so your dryness fraction is 0. This point is entirely vapor, so no liquid will be present, so your dryness fraction will be equals to 1. And this region both will be present, liquid and vapor, so your dryness fraction will be something greater than 0 and less than 1. Okay, if this thing is clear, this thing is clear, then we can move forward and let us understand that okay, what is actually happening. What is actually happening is that in saturated region, your volume is going to be equals to volume of liquid plus volume of vapor. This is your total volume. So can we say that total volume, suppose we are multiplying both sides with mass. What we are doing? We are multiplying both sides with mass. Okay. Or you can tell me this thing also, that let us convert this into specific volume. So this total volume, this will simply be equals to specific volume into total mass. This VL, that is volume of liquid, this will simply be equals to specific volume of liquid into mass of liquid, and this total volume of vapor, this will be simply equals to specific volume of vapor into mass of vapor. Because specific quantity, you know it, no? It will be simply V by M. Here nu L will be equals to VL by ML, and here nu V will be equals to VV by MV. Specific we have already discussed, any quantity divided by its mass. So from here, can you write that your nu M will be equals to nu L into L and plus nu V into MV. From here, your nu will be equals to nu L into ML by M plus nu V into MV by M. And what is this total mass actually? It is nothing but MV plus ML. So let us put in this equation. So our nu will become nu L into ml by ml plus mv plus nu v into mv by ml plus mv. That will simply mean nu l into 1 minus x and nu v into x, and that will simply give you nu l plus x into nu v minus nu l. This will be your nu, where your nu is specific volume, nu L is specific volume of liquid, nu V is specific volume of vapor. This derivation is clear? This derivation is clear? Very important. Very important. If this derivation is clear, so we said, okay, but we are engineers. We cannot keep things this much simple. We cannot keep these things this much simple. So what let us do is that we can represent liquid by F, that is nothing but fluid, and vapor by gas, G, that is simply by gas. So F means it is fluid, it is representing liquid, and anywhere it is G, small g written, that nu G, that means nu of gas. That means your vapor phase. This is just representation, nothing else. This is just representation to make it confusing. In that case, your nu will equals to nu F plus X into nu G minus nu F. Can we write this thing also? Can we write this thing also? जल्दी जल्दी बताओ, जल्दी जल्दी बताओ, जल्दी जल्दी बताओ, टाइम नहीं है. Okay. And we said that let us make things more complex, and let us say this nu g minus nu f as equals to nu fg, where nu fg will simply represent nu g minus nu f. So your nu, you can write it as nu f plus x into nu fg. This thing is also clear. We are doing nothing. We are just representing L by F and V by G, where F is the full form of F is fluid and the full form is gas is G. Gas. G is gas, where fluid means liquid and gas means vapor. Just representation. And we also said that okay, we have made it so much complex. We can let us make it more complex. So nu G minus nu F, let us represent by nu Fg. So that students get confused that whether to write nu F minus nu G or whether to write nu G minus nu F. यहाँ तक क्लियर है ना भाई? यहाँ तक एकदम completely clear है? And if this thing can be written for volume, if this thing can be written for volume, then in the same way it can be written for all other quantities. No, the way we derived it for your volume, that V is equals to VL plus VV, the same thing your H will be equals to HL plus HV enthalpy. Your internal energy will be equals to internal energy of liquid plus internal energy of volume. Your entropy will be equals to entropy of liquid plus entropy of gas. Sorry, entropy of vapor. Your specific nu matlab nu means nothing, it is just specific volume, so you can represent it by this thing also, 1 by rho also. So 1 by rho will be equals to 1 by rho liquid plus 1 by rho vapor. This thing also you can do, no? This you don't write. ये नहीं है, ये थोड़ा सा अलग टाइप का हो गया, ये थोड़ा सा गलत दिख रहा है, इसका हम बता देते हैं. Your nu simply means your specific volume, no? So specific volume, you know it, that your specific volume is just representing density. Your specific volume is nothing but density, sorry, 1 by density. What is the unit of specific volume? It is meter cube per kg. And what is the unit of density? It is kg per meter cube. Okay, so this is rho. This is nothing but 1 by rho. Okay, so you can write it in this number also. 1 by rho is equals to 1 by rho f plus x into 1 by rho fg, where 1 by rho fg is nothing but 1 by rho g minus 1 by rho f. This thing is clear. And similarly, if you can write this for your enthalpy, for your internal energy and entropy also, so from this single formula, you can also write these things, no? That your small h, that is your specific enthalpy, is equals to hf plus x into hfg. Your small u is equals to small uf plus x into ufg, and your small s is equals to small sf plus x into sfg. These things are also true, no? Because in the same way, we will derive it in the same way as we derived it for the particular volume. यहाँ तक क्लियर है? जल्दी से बताओ, जल्दी से बताओ. यहाँ तक क्लियर है ना? अबे भाई जल्दी बताओ, यहाँ तक क्लियर है ना? फुल क्लियर है ना? कोई कंफ्यूजन तो नहीं है? ठीक. Now let us understand one other concept, that is known as, let us understand that okay, in that way, how can we calculate the enthalpies at various point? How can we calculate the enthalpies at various point for your TV diagram? थोड़ा सा ऐसा हो गया, ठीक है? ऐसा मान लो, यहाँ पे इनिशियल स्टार्टिंग टेम्परेचर इज टी नॉट, दिस इज योर टी सैट, दिस इज ऑल्सो योर टी सैट, एंड दिस इज योर टी सुपर हीट. इसको टी एस यू पी लिख लो. ओके, सो दिस इज योर पॉइंट नंबर 1, दिस इज योर पॉइंट नंबर 2, दिस इज योर पॉइंट नंबर 3, दिस इज योर पॉइंट नंबर 4, एंड समवेयर बिटवीन दिस, ओके इसको चेंज कर लो, somewhere between this is your point number 3, this is your point number 4, and this is your point number 5. So will you be able to tell me, that what will be enthalpies at your point number 1, point number 2, point number 3, point number 4, and point number 5? So let us understand point number one. So at point number one, subcooled region, so only liquid will be present. So enthalpy will represent nothing. It will just represent the, what to say, it will just represent your क्या बोलते हैं उसको, hmm, क्या बोलते हैं भाई, बताओ, बता नहीं रहे हो. Hmm, heat. It will just represent the amount of heat involved, no, from T naught to T sat. Okay, so your this enthalpy at this position, the starting enthalpy, let it be H naught. That is, your liquid is initially present with H naught amount of enthalpy. Okay, your liquid is initially present with a H naught amount of enthalpy. Clear? Now let us move to point number two. So point number two, what will happen is that at point number two, what is going to happen is that point number two is, is on your saturated liquid curve. So let us represent by HF. Okay, so your HF will be is equals to the initial amount of enthalpy that is present plus enthalpy change. Now enthalpy change is nothing. Enthalpy change is nothing. It is just C into T saturation minus T naught. No. So this will be enthalpy at your point number two. At your point number three, this H will be is equals to HF, that is enthalpy till point number two, and plus your X into Hg minus Hf, because now X will come into play. At the enthalpy at point number four will be simply Hg will be simply is equals to Hg. And how you will get your Hg? Simply at this equation, if you put X equals to 1, so you will simply get it as Hg. And the enthalpy at point number 5 will be H is equals to Hg and plus C into Cp into T superheat minus T sat. This thing is clear or not? This thing is clear or not? Where your HF is enthalpy of saturated liquid and your Hg is enthalpy of saturated vapor. This thing is clear or not? ये चीज क्लियर है कि नहीं बताओ. X equals to 1 at point 4. This thing is clear, no? What I'm trying to say is that we will start from here. See, we will start from here. Point number 1. Okay. Initial enthalpy that liquid is having, let it be H naught. Okay, very good. Then we have to travel to point number 2. Now point number 2 is on a saturated liquid curve, no? So point number 2, the enthalpy, it will simply represent the enthalpy of saturated liquid. What will be this enthalpy of saturated liquid? It will just represent the initial enthalpy that it is present plus the enthalpy change, delta H change, the enthalpy change that will take place from going from point number 1 to point number 2. Now any other process is not happening, no, nothing we are considering, so the enthalpy change will be simply equals to heat transfer. So what is the heat transfer? It is C into T sat minus T naught, and for liquid and solids you know that your Cp is equals to Cv, so we are not writing Cp or Cv, we are just writing C. Once you reach to point number 2, for going to point number 3, what is going to happen is that the enthalpy at point number 3, it will simply be is equals to the enthalpy that is present at point number 2, that is your HF, and plus this dryness fraction into your Hg minus Hf, because Hg minus Hf will give you the enthalpy difference between these 2 points, between these 4 and 2 points, and how much amount of this change is happening, this will actually decided by your X, that is your dryness fraction, that is the amount of vapor present or amount of liquid present. Clear? Now, the moment you reach at point number 4, as because it is on the saturated vapor curve, so this will just give you your Hg. Your Hg will be equals to your H4. That is the enthalpy of saturated vapor. And that enthalpy of saturated vapor, well, how to get it? Just simply in this equation, you put x equals to 1. So once you put x equals to 1, you will get your H4. That will be equals to your Hg. This is simply is equals to your H2. Okay. And the moment you want to find out the enthalpy at point number 5, so point number 5 means what? You have reached already till Hg, and the heat transfer that is required for reaching from point number 4 to point number 5. So that is nothing but Cp into T superheat minus T sat. Now see here, very intelligently we have written Cp, because we know that this TV diagram is for a constant pressure process. So for a constant pressure process, what is the specific heat of gas? It is Cp. So very intelligently, for this gas phase conversion, we have written it as Cp. यह तो क्लियर है? जल्दी बताओ. Okay. Okay. One more thing I'm going to tell you. See here, very important. One more thing I'm going to tell you. Very important thing. Very important thing. See here. This Hg minus Hf. This Hg minus Hf. This is actually your latent heat. This is actually your latent heat. So in many questions of mass transfer or in heat transfer, you will find that you will be given enthalpy of saturated vapor and enthalpy of saturated liquid instead of directly your lambda. Many mass transfer questions in involving your reboiler and many heat transfer questions involving your evaporator, you will find that your H, instead of directly giving you a lambda condensation or lambda vaporization, they will only give you enthalpy of saturated liquid and enthalpy of vapor. But you have to remember this, that this Hg minus Hf, this is only your latent heat, no? For going from liquid to vapor phase, how much amount of heat is changing, you cannot represent it in terms of temperature, no, because it is happening in constant temperature. That is your latent heat. So this Hg minus Hf, this is simply equals to your latent heat, and that is nothing but lambda. This thing is clear. So in your heat transfer evaporators and your reboiler questions of your mass transfer, if you when you have to do this V bar into lambda in reboiler balance, you have to do, no, and for your heat transfer in evaporator, you have to do S into lambda, steam rate into lambda, that is equals to Q. Okay, these things you have to do, no. So if lambda is not there in the question, and instead of lambda your Hg and Hf is given, enthalpy of saturated vapor, enthalpy of saturated liquid, what you do is that you simply find out your lambda is equals to Hf minus Hg minus Hf. And many times this question comes many times. Okay, in all test series, very good test series, this type of questions will be there. Okay, so when I used to study, when I used to prepare, no, whenever I used to see this question, I used to think that okay, some data is missing. I think some mistake is there, something like this. I used to think. Okay, but no data is missing. It's a very intelligent question. It's a very question involving your thermodynamics, your pure substance. Your lambda is actually equals to your Hg minus Hf. Clear? So now your H3, you can write it as Hf plus x into lambda. And similarly, your H5, you can write it as, not x5, this thing is normal only, no? Hmm, this thing is normal only. Yeah, your Hg, that is equals to your H4, you can write it as Hf plus lambda. Because for this, your x equals to 1, no? For this case, your x is equals to 1. And from here, your lambda will be equals to your Hg minus Hf. ठीक है ना? बस different representation. Don't get confused. This is just the different representation. This is just the different representation. Okay. In this thing, in case number, in point number 4, you understood, no, what I did. In point number 4, I said that your Hg, actually you are getting your H4. So your H4 will be equals to your Hg. Okay, because that is just representing your enthalpy of saturated vapor. But if you move from this formula, that your H3 was equals to Hf plus x into Hg minus Hf. Okay, very good. So that means equals to Hf plus x into lambda. This is actually H3. So we said that your H4 will be simply is equals to H3 at point x equals to 1. Okay, so that will simply be equals to xf plus lambda, and your h4 is nothing but your hg. So from here you get your lambda is equals to hg minus hf. That's basically simple. Okay, so you put it, so again your h4 you will get it as hg. यहाँ तक क्लियर है? यहाँ तक क्लियर है ना? So now you tell me this entire, from here what you understood, the total enthalpy at point number 5, it will come out as, please understand, total enthalpy at point number 5, it will come out as Hg plus Cp into T superheat minus T saturation. Okay, where your Hg is actually equals to your Hf plus lambda and plus this quantity, that is Cp plus T superheat minus T saturation. And your HF is actually equals to H naught plus C into T sat minus T naught and plus lambda plus Cp into T superheat plus T sat. If they want you to calculate, if they will want you to calculate, so instead of giving you HF, they will give you H naught, they will give you T sat, they will give you T naught, they will give you specific heat of water, liquid water. Okay, they will give you latent heat of vaporization, and they will give you specific heat of water vapor at constant pressure, and they will give you all these temperatures, T sat, T naught, initial temperature, this is your initial temperature of liquid, initial temperature of liquid, and they will give you your T saturation, T superheat, sorry, T superheat, all these things they will give you, and you have to calculate entire this thing. They will give you that the phase change operation is taking place of a pure substance of water from a point in the subcooled region at temperature is equals to 10 degrees centigrade to a temperature of 110 degrees centigrade. So what is the total enthalpy change? What will be the total enthalpy change? It will be simply this thing, H5. ठीक है? This thing is clear. If this thing is clear for your enthalpy, then you already know that your entropy is nothing but enthalpy divided by your temperature, isn't it? Your entropy is nothing. It is just entropy by enthalpy by temperature. No, it is just heat transfer by temperature. No, getting it? No. So now let us calculate entropy at different points. Entropy at different points. So इसको थोड़ा फास्ट करेंगे, इसको तो उतना एक्सप्लेन करने का जरूरत नहीं है, एक्सप्लेनेशन वी हैव डन इट ऑलरेडी. So suppose you are having it like this, like this. Again, it will go from here to here, here to here, here to here. This is your T naught, this is your T sat, this is your T sat, and this is your T superheat. Okay. This is your point number 1, point number 2, point number 3 somewhere here, point number 4, and point number 5. What will be the entropy at point number 1? Entropy at point number 1, point number 2, point number 3, point number 4, point number 5. Now you should be able to tell, no? Tell fast, jaldi batao. Jaldi batao. At point number 1, what will be your S1? It will be simply your initial entropy, that is your S naught. It will be simply initial entropy, that is your S naught. This is S, small s, okay, isko small s naught. What will be the entropy at your point number 2? That will be represented by your S2. This S2 will be nothing but equals to your SF. This SF will be what? It will be simply initial entropy plus C ln T sat by T naught. For a liquid, what is the entropy change? It is C ln T by T naught, no? T2 by T1, no? MC ln T2 by T1, no? For a liquid. For a liquid and a solid. Because for a liquid and a solid, volume does not change. This thing we have already discussed in entropy. क्या तुम लोग पढ़ाई नहीं किया क्या भाई? जल्दी बताओ. This thing is clear, no? For a liquid, and first we derive the entropy for the ideal gases. Then we said that for liquid and solid, the volume does not change. So your entropy will be equals to C into ln T2 by T1. ये चीज पता है ना? बता ही नहीं रहा है. Okay. At point number 3, your S3 will be simply equals to SF plus X into SG minus SF. At point number 4, your entropy S4 will be simply is equals to Sg, that will be simply is equals to S3 at x equals to 1, and at point number 5 your uh, S5 will be equals to your plus S4 plus CPV into T superheat by T saturation, where your S4 is nothing, it is just Sg. So CPV into ln T superheat by T saturation. यहाँ तक clear है? Where CPV is nothing, just it is just specific heat of vapor at constant pressure. It is just specific heat of vapor at constant pressure. Okay, don't be worried. And what is your C here? It is just specific heat of liquid. Your P is specific heat of liquid, and your CPV is, if you're getting confused but for writing CPV, you can directly write CP also. Okay, don't get confused anywhere. Okay, so your CP will be simply specific heat of gas at constant pressure, because you know that your TV diagram is drawn at constant pressure. No, again here see, यहाँ तक क्लियर है ना? जल्दी बताओ, यहाँ तक क्लियर है? यहाँ तक क्लियर है? Okay, again here see, again here what is going to happen is that, very important, this Sg minus Sf, can we write it as, you know, it is entropy change, so entropy change will be heat change divided by temperature. So can you write your Sg minus Sf by Hg minus Hf divided by Tsat? And also you know that Hg minus Hf is nothing but lambda, so lambda by Tsat, or latent heat by Tsat. So from here your S3 will be equals to Sf plus x into lambda by Tsat. जल्दी बताओ. Your Sg will be equals to Sf plus lambda by Tsat. You have put x equals to 1. And from here, your S5 will be is equals to Sf plus lambda by Tsat plus Cp ln T superheat by Tsat, where Sf is nothing but S2 and your S2 is nothing but S0 plus C into ln Tsat by initial temperature T0 plus lambda by Tsat plus Cp ln T superheat divided by Tsat. This is your S5. And now if it is asked to you that what is the total entropy change for for a glass of liquid to go to superheated, a glass of liquid at 10 degrees centigrade to go to superheated vapor at 110 degrees centigrade, will you be able to tell it? It will be simply S5 minus S0, that is equals to C liquid into ln Tsat by T0 plus lambda by Tsat plus Cp ln T superheat by Tsat. This is entropy change. So if you are asked directly the entropy at 0.5, or the directly, you may be asked in these two ways. Okay, generally for entropy they asked it for entropy change only. Okay, so it can be anything. Suppose it is asked to you that suppose it is asked to you that okay, find out the entropy of the superheated vapor at 110 degrees centigrade, so directly you will calculate your S5. Okay, suppose it is given to you that it is 1 kg of steam, so multiply it with m, or 2 kg of steam, so this we are calculating in specific format, that's why it is small, so multiply it with 10, multiply it with the mass that is given to you, it will convert into normal entropy. Clear, no? Anything asked, you must be able to tell. Okay, suppose it is asked entropy change. So entropy change will be given by this format. Okay, suppose it is asked directly only entropy. So this will be given. Just multiply it with m. It may be given to you that we are thinking of a process. See how your questions can be formed. Very, very important questions can be formed. It can be given to you that we are thinking of a process of taking m is equals to 1 kg. Now suppose any mass is given to you. Mass we are thinking of 2 kg. Okay, see here कितना beautiful question बनेगा देखना इधर. देखो ऐसा बोल सकता है कि सपोज मास इज इक्वल्स टू 2 kg. ओके, mass of 2 kg of liquid you are having. You want to convert, this is at 10 degrees centigrade. You want to convert this into superheated vapor at 110 degrees centigrade. Okay. However, it is given that the specific heat of this liquid is something given to you, and the specific heat of the vapor is something given to you. Okay. So you will be said to find out that whether this process is feasible or not. This process is feasible or not. That means this process is possible or not. So how will you find out? How will you find out? देखे कितना समझे हो थर्मोडायनेमिक्स. थर्मोडायनेमिक्स कितना समझे हो, इतना जो क्लास करवा है उससे देखे. How will you find out that whether this process is feasible or not? You want to go from subcooled liquid to superheated vapor. These values are given to you, that Cl and Cp. Just tell me the concept. I don't want to get into values, okay? Because this is just a question I'm thinking of. So I don't want to go into values. You just tell me the concept, that what concept you will use. बता ही नहीं पा रहे हो. Suppose it is given that the boiling point of this liquid is equals to suppose 95 degrees centigrade. So this is also given to you. So everything is given to you. So just tell me the concept, what concept you will use. I just want to check that whether you are able to think or not. No, no, no. You have caught, like you have caught the right concept, but didn't answer correctly. The concept you have caught it, but you couldn't answer correctly. So the first thing you will do here is that suppose this initial entropy, this S naught is given to you. This will also be given to you. These are all given. So the first thing you will have to do is that you will calculate your S5 minus S naught. This value you will calculate from the same way we have done this thing. Okay. After calculating this, so this is your total delta entropy change. After calculating this, you will check that whether this value is greater than or equals to 0 or not. If it is greater than equals to 0, that means positive entropy change. That means this process is feasible. Because what we have discussed is that for all processes happening in the universe, your delta S must be greater than equals to 0. It can never be possible that your delta S is less than 0. And from here only we say that word, that entropy of the universe always increases, or entropy is always increasing. We are doing any activity, but we are participating in the entropy. We are increasing the entropy. So your delta S must be greater than equals to 0 for all processes, for anything that you do. Okay. So first you have to check that whether your delta S is greater than equals to 0 or not. If your delta S is coming less than 0, that means negative. In that case, the process is not feasible. Okay, very good. Now the question can be formed in this way also, that it is given to you that the process will be feasible. It is asked that whether it is a reversible process or irreversible process. So how will you decide that? Simply again the same thing. You will calculate your S5 minus S naught. If delta S is equals to 0, then this will be a reversible process. And if delta S is greater than 0, then it will be an irreversible process. These things we have discussed in enough detail when we were doing entropy. Even if we, even if it was a crash course, but still we discussed all these things in very details, no, in a very short amount of time. So like this in gate questions may come. Okay, till now it has not come, but it will come. These are like very intelligent question. In the subsequent years, it is going to come. They will go into that this much deep concepts. Okay, the same thing. Everybody knows that LTS is greater than equals to zero. Okay, but you have to apply this along with pure substance, a mixture of concepts. Getting it? No, mixture of concepts, mixture of pure substance and mixture of your entropy. Two concepts will be mixed and they will give you a very intelligent question, and they will give you very easy values in this. Okay, so that your calculation part for this thing, the calculation part becomes very easy. They will give you very easy values. Okay, lambda they will directly give to you. All these things will be there. Okay, it may happen that they don't give lambda, they give hg and hf. So again the same thing, your lambda will be equals to hg minus hf. Okay, so you must be able to play with everything. Okay, you're getting it? No, so you must n number of times if you revise it, so all these things, all these concepts will be there in your brain. So automatically you will be able to think of the questions. Okay, like now I'm thinking of the questions. No, that how questions, like framing, we will be able to frame questions. Okay, these things will happen if you like get concepts, like if you understand concepts very properly, so these things you will be able to do. Okay, and this thing we have completed our pure substance. Okay, but still when you will go to solve the questions, no, of pure substance, direct questions you will be able to solve it, but little turbine questions will be there, all these things will be there, you will not be able to solve it. We have completed entropy, we have completed pure substance in very detail. Okay, this thing is okay. No other concept is there in pure substance other than this. Okay, but still when you will go to solve the question, no, you will not be able to solve it. So for that we will have a question session tomorrow. Then we will solve some questions, and after that you will be able to solve all the questions. Okay, प्योर सब्सटेंस क्लियर हुआ? जल्दी बताओ. प्योर सब्सटेंस इज क्लियर. हाँ, होता है, होता है, होता है. चलो उसको कल कल क्वेश्चन डिस्कस करेंगे, उसमें करा लेंगे. उसमें कुछ नहीं, जेड का कंसेप्ट होता है, कंप्रेसिबिलिटी फैक्टर होता है. ओके, ओके, दिस थिंग इज क्लियर नो? यहाँ तक क्लियर है ना भाई? जल्दी बताओ. ठीक है. रिड्यूस प्रेशर रिड्यूस टेम्परेचर कंसेप्ट वो बहुत इजी कंसेप्ट है. उसमें हम लोग आइडियल और रियल के केस में करते हैं. ठीक ना? आइडियल और रियल के केस में करते हैं. ठीक है. हम लोग क्या, yesterday when we were discussing our that solution thermodynamics, no, so there we saw, no, that for your ideal gas your p is almost tending to zero. That means you are having a reduced pressure. So if your pressure is reduced, then also you will get a reduced temperature, no. So for your ideal, you can write it that PR VR is equals to Z is equals to RT. Okay. But for real, you have to write PV is equals to ZRT. Okay. So from there, you have to find out some relations. Also, Van der Waals equation can be involved in that. Okay. So nothing. It is very easy concept. You have to just take ratios and find out the unknown thing. Okay. One table will be given to you. One question in PYQs. Two questions. One question earlier and one question recently. I think in 2021 came. Okay. So very easy questions. You have to just take ratio and find out the unknown thing. I'll discuss it tomorrow. Don't be worried. Okay. Just make me remember one thing. When I will be forming the questions, no. So one question of this thing also I will involve. Of your reduced pressure, reduced temperature, reduced. ठीक है. दो ही बार क्वेश्चन आया है. एक बार पहले आया था और एक बार 2000 लाइक रिसेंटली 2021 में आया था. Okay. Okay, so enough. That was all about our pure substance. So thermodynamics is completed. Okay, I will take up boiling and condensation. Okay. बॉइलिंग एंड कंडेंसेशन कल हम लोग क्वेश्चन सेशन करते हैं. कल थर्सडे है. फ्राइडे को हम लोग बॉइलिंग एंड कंडेंसेशन कर लेंगे. ठीक ना? एंड देन संडे विल बी योर एप्टीट्यूड. ओके, देन आफ्टर दैट फ्रॉम मंडे वी कैन स्टार्ट अवर एफएम. ओके, सो दैट विल बी अवर पॉइंट. चलो. ठीक है. थर्मोडायनेमिक्स समझ में आया कि नहीं बताओ? पूरा थर्मोडायनेमिक्स इज कंप्लीट टुडे. सो डिड यू अंडरस्टैंड थर्मोडायनेमिक्स? Actually, it's a very hard subject. Very hard means it nothing hard is there. Actually, it's a very conceptual subject. Okay, so that's why no teacher, every teacher you will find that they are teaching mass transfer, IPC. IPC to everyone teaches because it is not conceptual. No, it is just formula based. Okay, heat transfer. That much not formula is involved. Sorry, only formula is involved. That much concept is not involved. So everyone will be teaching. But thermodynamics, no one teaches. Hmm. Because the moment thermodynamics comes, many concepts are involved here. No, like thermodynamics is a natural. Thermodynamics is a natural thing. Okay, natural thing means everything is based on your nature. Like this thing you understood, no? This example, this concept, that why from solid to liquid water contracts and from liquid to solid it expands. Okay, so thermodynamics is based on your nature. Classical thermodynamics is simply based on your nature. Everything that is happening around you is thermodynamics. Okay, so it's a very conceptual thing, very nature based thing. So that's why no teacher teaches it. It's very difficult to study it, no? वो आईपीसी का फॉर्मूला सबको आके लिख देगा, समझा? यू विल सी मेनी सेशंस इन यूट्यूब. ओके, आईपीसी फॉर्मूला रिवीजन, हीट ट्रांसफर फॉर्मूला रिवीजन. ठीक है, सिर्फ आके फॉर्मूला लिख के चल जाएगा. फॉर्मूला रिवीजन बहुत इजी है भाई, कोई दिक्कत नहीं है, सब कोई कर लेगा. तुम एक बार तैयारी करो, तुम अगला साल से करवा देगा. क्या करना है, देख के फॉर्मूला तो बस लिखना है. कॉन्सेप्ट तो कुछ है नहीं उसमें. ठीक है, लेकिन थर्मोडायनेमिक्स का कोई फॉर्मूला रिवीजन, कोई कंसेप्ट रिवीजन. हाँ, थर्मोडायनेमिक्स में यू विल सी सॉल्यूशन थर्मोडायनेमिक्स. द सॉल्यूशन थर्मोडायनेमिक्स इज हैविंग ओनली formulas, it is not having any concept. Okay, so solution thermodynamics revision everywhere it is going on 10 times, 20 times. Okay, solution thermodynamics का 50 कोर्स आ गया है. ठीक है, सब कोई पढ़ाता है सॉल्यूशन थर्मो. लेकिन क्लासिकल थर्मो जैसे ही आता है फिर कोई नहीं, कुछ नहीं, उसका कुछ नहीं मिलेगा. ढूंढ लो जाके पूरा, उसमें कुछ कुछ नहीं है. कुछ कुछ नहीं, क्योंकि नहीं, कोई कोई नहीं लेगा ना, रिस्क नहीं लेगा ना इसमें, समझ रहा है ना, इसमें तो रिस्क की चीज है. ये तो पूरा एकदम तुमको, दिस थिंग इज सच अ थिंग, thermodynamics is such a thing that your concept must be 100% clear, or you will not be able to teach it. That is the thing, no? Like suppose you directly ask me here only that, sir, why this thing water, for water why this why this exception happens. Okay, for all the substance this is happening, but for water this is happening, why? Okay, so someone has to know this thing, no? This thing of nature, that it is designed by God. अगर वो नहीं होता तो फिर वाटर ऑर्गेनिजम्स विंटर एरिया में, कोल्ड रीजन में सर्वाइव ही नहीं कर पाता. ठीक है. ओके, एनीवेज वी विल एंड दिस क्लास नाउ. इसे फर्जी का बात करके टाइम वेस्ट करके कुछ फायदा नहीं है. क्लास एंड करते हैं, जाके पढ़ाई करो, ज्यादा टाइम बचा हुआ है नहीं. ठीक है, एप्टीट्यूड हम लोग खत्म कर देंगे संडे को, और नेक्स्ट संडे हम लोग सिटी खत्म कर देंगे. ओके, सो यू आर हैविंग डाउट्स इन टू सब्जेक्ट्स, सिटी एंड एप्टीट्यूड. वी विल कंप्लीट दीज टू सब्जेक्ट्स इन योर Sunday and upcoming Sunday, next Sunday and the Sunday after that. Okay, so then only thing that will be left is your fluid mechanics. So fluid mechanics हम लोग मंडे से, बीच में जो टाइम मिलेगा मंडे टू फ्राइडे, वी विल कंप्लीट अवर फ्लूइड मैकेनिक्स. ठीक है, तो तुम लोग का अच्छा खासा प्रिपरेशन हो जाएगा भाई. इसके बाद बस रैंक ले आके दे देना अंडर 100. ठीक है, तो थोड़ा सा अच्छा रहेगा, क्योंकि रिजल्ट इज एवरीथिंग. इफ यू स्टडी वेरी हार्ड बट इफ यू डोंट गेट रिजल्ट, देन देयर इज नो पॉइंट ऑफ स्टडिंग. पीडी, पीडी वीडी तो एक एक दिन का सब्जेक्ट है. इट इज जस्ट अ वेरी स्मॉल. पीडी, एमओ, पीसी, दीज आर वेरी स्मॉल सब्जेक्ट्स. Only formulas, no? See, you should be afraid of your conceptual subjects. Okay, formula based subjects, nothing is there. No, you just have to memorize the formula and solve questions based on those formulas. Okay, PD maybe a little bit of concept is involved. Okay, like very little concept and too much formula, so we will do it in very less amount of time. These are very like lightweight subjects. प्रॉफिटेबल एनालिसिस अब कुछ नहीं है. प्रॉफिटेबल एनालिसिस क्या होता है? प्रॉफिटेबिलिटी होता है, उसका 7 तरीका होता है. उससे हम लोग बस ये दिखाते हैं कि कोई भी कंपनी जो चल रहा है वो इन्वेस्टेबल है कि नहीं. ओके, सपोज यू ओपन अ कंपनी टुडे, सो यू विल हैव टू पुट इन सम मनी एंड यू विल जनरेट सम मनी. ओके, सो profitability, that is only known as your profitable analysis. It just represents that your company is investable or not, if from an investor point of view, that I should invest in this company or I shall not invest in this company. Okay, so 7 parameters are there. ठीक है, वो क्या क्या पैरामीटर है, वो तो क्या क्या होता है. एक तुम्हारा रेट ऑफ रिटर्न होता है, एक तुम्हारा इंटरनल रेट ऑफ रिटर्न होता है, कैपिटलाइज्ड कॉस्ट होता है, ओके, एनुअलाइज्ड कॉस्ट होता है, एंड देन योर आई थिंक योर क्या होता है उसको, वो और चीज होता है ना, जो ईयर बताता है कि कितना ईयर में वो उसका जीरो हो जाएगा, ब्रेक इवन पॉइंट। हाँ ठीक है, बता देंगे, कोई दिक्कत नहीं है। एनपीवी होता है मेन चीज, तो उसमें एनपीवी होता है, नेट प्रेजेंट वैल्यू, दैट इज द मेन थिंग। ओके। Okay, anyways, we will discuss, we will do PDE. There's a very light subject, so no need to get tension about that. You complete your thermodynamics. Okay, tomorrow we will have the that question session. After that, before Sunday, you complete entire thermodynamics. Okay, boiling and condensation we will discuss day after tomorrow. That is on Friday. Saturday your class will be off, and Sunday we will be doing aptitude. Okay, chalo, bye.